Okay, thank you, students. Uh, in today's class, I'm going to talk about the primal and dual. What is a primal and what is um, a dual? So, by giving an example, I will give you the total description about the differentiation between the primal and dual. Let me go to the topic now. Let us have this. Now look at this. This is what we call primal. Okay, this is called primal. Maximum z equals 3x1 minus 4x2 subject to 7x1 plus 5x2 is greater than or equal to 0. 2x1 plus x2 is less than or equal to 2, where x1 x2 are non-negative, that is greater than or equals to 0. Now look at this dual. Now how I made this: instead of maximum I have taken minimum, instead of z I have taken another variable w. Now look at this. um, Look at the constraints. Here we have 10 and 2. Am I correct? 10 and 2. By taking this as the coefficient, by taking this elements, this column as a row for the objective function, I made an equation like this. Okay, so let y1 y2 be associated duality variables. Y1 y2 are the associated variables. Then this 10 into y1 plus 2 into y2. Look at this very carefully. This is constraints. So this side, what are the constant are there, I am taking as the coefficient of the objective function with associated with the dual variables, right? So this 10 becomes the coefficient of y1 in the objective function, and this 2 becomes coefficient of y2 in the objective function. Okay, right. Now what happened to this, the coefficient of objective function here? Look at that. 3 is coming here and minus 4 is coming here. I mean, the coefficient of the primal becomes the constants on the right hand side of the constraints in the dual. Okay, the coefficient of the objective function in the primal becomes the right hand side constant of the constraints in the dual. Okay, so that's what we have here. Then this greater than becomes less than, and this less than becomes greater than. This greater than of sign in the constraints of the primal becomes less than or equal to in the duals constraints. And so that's what we see here: greater than, here less than, greater than. One more thing, how this part comes. Okay, now look at this: 7x1, 7x1. Okay, so this column you write as a row, this column you are writing as a row. 7 y1, 7 instead of x1 I have it as 7 into y1, and then this number plus 2 into y2. So this column becomes the row here. Okay, 7 y1 plus 2 y2. Then how this comes: 5 y1 plus y2. 5 y1 plus y2 is less than comes here, so greater than or equal to, and like that. So where these two dual variables are non-negative. Okay, so I repeat again. The maximum becomes minimum, and then the coefficient in the objective function of the primal becomes the right hand side constant of the constraints in the dual, and then the right hand side constants uh, of the constraints in the primal becomes the coefficient of the objective function in the dual. Okay, in the dual. And then how the constraints of the dual formed 7 y1 plus this column becomes row 7y1 plus 2y2 is less than or equal to 3. This greater than becomes less than or equal to, and this 5y1 plus y2 is greater than or equal to minus 4. So this is a way we can get dual from the primal. So what you understand is nothing but the row here becomes column here. Okay, row here becomes column here, and column here become rows here. That's what we say transpose. Am I correct? So if the primal is given to us, if you find transpose of the primal, then it will be called a dual. So transpose of the primal is called a dual. Okay, so thank you very much.